All right, I've been spoiling you over the past couple lessons. They've been super short. I've been saving up for this one. This one's a lot longer. It's not anything new to you. It's all Algebra 1 stuff, but they cram a lot of stuff from Algebra 1 into this lesson. So let's go. Okay, this is equations of lines. Now, we're looking at the coordinate plane again. So the first thing you want to do is look at the slope. If you're looking at a graph, we think of the slope as the rise over the run. That's one way to look at the slope. If you're looking at ordered pairs, then we use this slope formula that should be familiar to you. Y minus y over x minus x. So what's the slope of the line through these 2 points? Well, since they're giving me points, I'm going to use the formula, and I'm going to set it up. You can see that I've tried to label everything. Here's the first point, so that's my x1 and my y1. Here's my second point, x2 and y2. If I'm going to set this up, then I'm going to say m. If you remember, slope is m equals, and then I'm going to take y2. That's a -2. And then it's always a minus sign here, and then I subtract the y1, which happens to be a 0. In the denominator, I do the same order. It really doesn't even matter which point you designate as your first point and your second point, as long as you're consistent that you do the same thing, like you use the same point here that you use right here. All right, so I've got my x2 is a 3 minus x1 is a -1. All right. In the numerator, -2 minus 0 is just -2. In the denominator, I have minus minus, which I'm going to change to plus plus, which is a 4. Then anytime you have a fraction that will reduce, you want to make sure you do that. My slope is -1/2. Now another way to find slope is from a graph. And if I'm going to do a graph, they've been kind enough to give me ordered pairs here, so I could do my slope formula if I wanted. But really, if I've got it graphed, I'm just going to count my rise and my run. Now you always want to read your graph from left to right. So I'm going to go from this direction, I'm going to follow my line this way. And then you're going to count your rise first, and then your run. To get to from one point, they've notated a point here, to the next point they've notated as right here. So to get from here to here, my rise is actually a negative number because I'm having to go down. So I went down 4 units. When I write my slope, that'll be my rise over my run. My run actually went to the right, so that's positive 5 units. So there's my run. Slope of that line is -4/5. Now when you're talking about slope, it's nice if you start anticipating what's going to happen with it. If you have a line that is headed uphill, they call that uphill, going upward, as you read it, left to right, that's going to always be a positive slope. But if you have a line that's headed downward, like our last one did, it was headed downward as you read it left to right, that's always going to have a negative slope. Horizontal lines have 0 slope, and vertical lines will have undefined slope. We'll talk more about those later on, but it's helpful if you're anticipating what your slope should end up being. All right, so moving on from slope, let's talk about linear equations. There's different forms of linear equations. You should have seen both of these. You've got slope-intercept form. That's a very, very common form. It's y equals mx plus b. That probably rings a bell for you. The m represents your slope, and the b over here represents the y-intercept, where it touches the y-axis. We use this form a lot. It's great for graphing, or when you're looking at a graph, you can identify these 2 pieces pretty easily from a graph. Now another form that we use is called point-slope form. And it's kind of personal preference. Sometimes it's the personal preference of your Algebra 1 teacher on which one of those you use more often. But the point-slope form works nicely if you know a point and you know the slope. Because what you do is you just put in the coordinates of your point. So here goes the x and here goes the y of the point that you know. And you put in your slope right here. The other y and x stay in there as part of the equation. So it goes y minus y, and mx minus x. All right, so I threw up there that slope-intercept form again because I want you to use that. I told you that was nice for graphing. So could we graph this one? It's in nice slope-intercept form. You have to pick out these two parts of it, so let's go ahead and pick those out. Let's find the y-intercept. The y-intercept is that number that's being added out at the end, so that is going to be a 1. The y-intercept on my graph is 1. And then the slope is your coefficient on your x, and you can see that's right here. That's the coefficient on my x. I have a slope of 2/3. Now, I'm going to graph that by starting with that y-intercept. That's kind of my starting point. It's going to start at 1 on the y-axis. And then from there, I just count my rise over my run. It's going to rise to run, oops, kind of trying to show you that. Maybe I can show you this way. From my point, it's going to rise to run 3. Put a dot there. Rise to run 3. Put a dot there. And so you put a few dots across your graph. You can also back that up. I know my slope is 2/3, but if I had made both of those negative, wouldn't a negative divided by a negative still be a positive? So I actually could look at it that way. I could go down 2 and left 3. It still lines up. Down 2, left 3. It's nice to get a whole bunch of points there so you can keep your line really accurate when you draw it. So this is the line represented by this equation right here. All right, how are we doing so far? Is this all coming back to you? I'm hoping. This is another form, okay? This probably not as common, I'd have to say, but if I give it the form to you like this, and you can see that this next example, I've given you this equation in this form, could we graph that? Well, we can still graph that. It's just I'm going to be looking for different things. Instead of looking for the y-intercept, I'm going to start with my point. Now my point is, here's the x, it's grouped with the x. Here's the y, it's grouped with the y, but notice that the formula says minus. So right here, it's whatever you're subtracting, and since I'm subtracting 3, then my y value is 3. But if you'll notice that I'm adding here, well, the only way that I could be adding here is if I'm subtracting a negative. So that's actually going to end up being a -3 for an x value. I have a -3 for my x value, a +3 for my y value. It always ends up being the opposite sign of what you see right here in your formula. All right, the next thing is to pinpoint the slope, and that's just the number in front of your parentheses. It's a -2. If you're graphing, sometimes it's nice to think of that -2 as over 1, so you see your rise and your run. Now you're going to go graph. You start with your point, you plot -3, 3. There's my starting point, and then I count my slope from there. So I'm going to go down to right 1, down to right 1, down to right 1. I could switch where that negative goes. It's just a -2. Couldn't I also have written it like 2 over -1? So I could rise to left 1, rise to left 1. Either way, get a few points in there, draw your line. Okay, so these are for you. I gave you one that's in slope-intercept form. I gave you one that's in point-slope form, doing what we just got done doing. All right, it's important that you practice this stuff on your own without just me doing all of it. So take the time, pause your video right now, and go do these two on your own. Come back when you're done. All right, this is what I ended up getting. Check yours, see if you agree. If so, keep moving. If not, pause and figure out what you did wrong. A couple things I did want to point out over here on the right. Notice that the slope was -1/3, and the negative they stuck out in front of the fraction. You kind of have to commit to where you want to put it. You have to put it on top or on bottom. Don't put it on both because it ends up going positive, because a negative divided by a negative would be a positive. Put it on one or the other. I like to put it on my numerator because I think of rise better as going down. The other thing you might notice is you started right here, and then you went down 1, right 3, and then boom, you're off your graph already. So that's the time where you definitely want to kind of be stretching it the other direction and thinking it the other way around. All right, I'm going to keep going. Okay, now we're going to get into the writing equations of lines. I'm telling you, we're hitting everything you did in Algebra 1 on lines right here today. Writing equations. All right. Which form you use can vary. You can do slope-intercept or you can do point-slope. Kind of depends on what they give you. This one says, what's an equation of the line with slope equal to 3? Okay, that's going to be your m value right there. And y-intercept is -5. Well, they're handing you the y-intercept. That would lead me towards slope-intercept form because that's going to be my b value right there. So if I'm going to do slope-intercept form, all I have to do, they gave me exactly what I wanted. All I have to do is put in those numbers. It's going to be a 3x, and then for my b, it's a -5. And that's my equation. They couldn't have handed me anything better there. Let's make it a little harder. What's the equation of a line that goes through this point and has a slope of 2? Okay, the 2 is going to be my m. And this is my ordered pair x, y. Now there's going to be 2 ways that you can do this. I'm going to show you both ways here, and then why don't you pause the video and just write the way that you want to use, because I don't care which way you do it. All right, so I'm going to start with point slope because that's what they gave you was the point and the slope. So it'd be y minus y, and it's really like, remember that the first y stays put and the second y is what you replace. Equals m, and then it's an x minus an x. So I'm going to leave my first y and then subtract the y from my point. So it's going to be a -5. Equals m, that's 2. The first x stays put, the second one gets replaced with my ordered pair. So it's minus -1, that's going to turn to +1. Typically, we don't leave it in this particular form, and you'll have to kind of pay attention to directions on your homework on whether you're supposed to leave it in point slope form, or if they want you to go ahead and keep going and clean it up a little bit and put it into slope intercept. If I were to put this in slope intercept form, I'm going to distribute. And then I'm going to add the 5 to the other side. So my final answer would be y equals 2x plus 7. Now, did you remember you were just watching? You weren't supposed to write anything there. Because I've got another method for you you might like instead. Let's try that. You can also go through slope-intercept form. That's the y equals mx plus b. And I'm going to plug all 3 of those things in. The m, the x, the y. And then the only thing missing is going to be the b. So I'd have a 5 equals 2 times -1 and then plus b. And what I'm doing here is I am figuring out what the b is. So 5 would equal -2 plus b. Add the 2 to the other side and I'd have b is equal to 7. Got it. Okay. And if b is equal to 7 and m is equal to 2, then I can write my equation in slope-intercept form. Y equals m, so that's 2x plus b, there it is, plus 7. Do you see I got the same answer? Doesn't matter which way you do it. Now pick one of those methods and write it in your notes, and then you can just do it that way. It doesn't matter to me which one you do. Okay, so what is an equation of the line with slope -1/2 and y-intercept 2? Based on what they give you, you should be doing slope-intercept form there. The second one, they give you a point and slope. And again, you can't just watch me do them all. You got to try some by yourself. Pause the video right now. Do these 2 on your own. All right, check your answers with mine. The first one should have been pretty easy. Second one, I gave you both options. You did not need to do it both ways at all. Just, I wanted to show you so you could check your work. Those are the 2 different methods. You should have gotten y equals -3x plus 1. Pause the video and look it over. If you missed it, Otherwise, let's keep going. Okay, again, still writing equations and lines, but what if I gave you a graph? Could you figure it out from that? Now this is suggesting that I do it in point-slope form, and I can kind of see why, because my y-intercept doesn't appear to be very pretty here. I'm not exactly sure where that's falling. It maybe looks in the middle, but I'm not positive that it is the middle. So they're suggesting point-slope form. And since they say that, I'm going to even leave it in point-slope form. I'm not even going to convert it. But here's the deal. I have options. Do you want to use this 3, 5 point, or do you want to use this -2, -1 point? If I had to guess, you're probably saying 3, 5. I'm going to avoid the negatives. Okay, that's fine. So then you would write y minus y, so that's the 5, equals m. Oh, I haven't found my slope yet. I should have started with that. Sorry. All right, so let's count our slope from one point to the next. Remember that you're going left to right, so I'm going to go from this point up to this point. So here we go. Rise 1, 2, 3, 4, 5, 6. Run 1, 2, 3, 4, 5. So my slope is 6/5. That's not very pretty, but it is positive because my line is headed upward, so it's a positive slope. And then I would do x minus my x value, which we would go with that 3 there. And so that would be what I'd write. Now, we chose that point. We could have chosen the other, so I'll go ahead and write it because you would have two options here. You could have gone instead of y and use this other point, y minus -1. That's going to be +1. Slope is still going to stay the same. And then I'm going to have x minus my x value, so that's a -2. X minus -2, it's a +2. So I might have written this. Either one of those is acceptable. All right, let's say we already have the equation, but it's just not in the form that we want. So in this example, this is actually called standard form, and this has its own place. It's not great for graphing, but there's a reason that we use standard form. We're not going to get into it today, but if I want to rearrange it and get it put into slope-intercept form, I need to get my y by itself. Okay, so let's start working on how would you get that y by itself. Well, there's a couple things I need to get rid of. This 3x totally needs to be gone, so I'm going to move it over here. And then this 5, I don't want that there either, so I'll get rid of that. I usually work towards the y, so I'm going to start with the farther out stuff. I'm going to get rid of this 3x first. It's being added to the 5y, so I'm going to subtract it. Minus 3x minus 3x. Now I'm left with my 5y sitting here. And on the other side, these are not like terms. I can't combine them because the 3 has the x on it. Now I do want it to look like this. I want the mx and then the b. So I'm going to write the -3x part first and then the -10 after that. So it looks like it's in that form. Now I have to get rid of that 5. That 5 should not be there. It's being multiplied by y, so to undo that I'm going to divide by 5. But I have to divide everything by 5 if I'm going to do that. So that cancels, and I get y equals, that's a -3/5 x is how you'd write that. So your -3/5 is your slope. And then this actually came out nice to a -2. That ends up being your b, or your y-intercept. So you'll have to do some rearranging of some equations to get them in the form you want, because now this would be really easy for us to go graph once it gets put into the slope-intercept form. Okay, let's move on to something new here. We briefly spoke about horizontal and vertical lines previously. Horizontal lines, they're going to want us to write, it says, what are the equations of the horizontal and vertical lines through 2, 4? Okay, horizontal lines only have one variable. So do vertical lines, but they have different variables. If you look at this horizontal line, the thing that always stays the same is from the origin, you are always up 4 units. Doesn't matter where you're at on that line, you are up 4 units, which means every point on this line has a y value of 4. The equation of that line is y equals 4. That's how you write it. So now look at the vertical line. What do you think that will look like? From the origin, every point on this line is going to be right 2. It's going to have an x value of 2. Right 2 and then up or down or whatever you want to do. But the x value for every point on that line is 2. So the equation is x equals 2. Now, what you're going to have to remember is that the horizontal line is a y value. I think of it as it crosses the y-axis at 4. You can see that it crosses the y-axis right here at 4. Vertical line is going to cross an x-axis, and in this case it crosses at 2. They give you this ordered pair to help you, and you can see that, oh, the x is 2, that's the vertical, y is 4. We have a cute little acronym that helps us remember that, and perhaps your Algebra 1 teacher taught it to you, perhaps not. I kind of like it, so I'll go through it. HOIVUX, if you just remember that little acronym, HOIVUX, but what that means is horizontal lines are going to have a 0 slope. We talked about that earlier, way early in this lesson. Have a 0 slope. And their equations are always y equals some number, maybe 5, y equals 5. And that may be confusing. Maybe you just want to say y equals a number or something, but there's no x in the equation at all. Okay, takes us over to VUX, vertical lines have undefined slope, and their equations are always x equals some number, be it 5 or 2 or -4. There's just going to be x equals a number, and there's not going to be a y in that equation at all. So horizontal and vertical lines have special equations. They're really pretty simple little equations, but because they're so simple, sometimes that makes them different and makes them tricky. Remember HOIVUX. All right, so then that takes us back to the last question, which is similar to the one we did earlier there, but this one's a got it, which means you have to do it by yourself. Could you write the equation of the horizontal line and the equation of the vertical line that go through this point for -3? Pause the video and write your two equations. Okay, the easy way to do this is to remember HOIVUX. Hoi, H goes with Y. This is going to be a Y equals. VUX, vertical, goes with X. This is going to be an X equals. And all you really got to do is say, okay, the Y's are always what? Well, look at your ordered pair. The Y is -3. Okay, and the X's are always what? Oh, the X's are always 4. And those are your two equations. All right, that was a lot of information in one day. I hope you don't totally forget your Algebra 1 stuff, but go give it a shot. Good luck.